Alrighty, so we're going to move on from absolute value functions to square root functions. So this is something that you came across in Algebra 2. This is the form that these are in. It should look familiar because it is similar to our absolute value functions. And these are going to do pretty much the exact same things to our graph that they did to absolute value functions. So our number inside our radical is going to shift us left or right. Same as absolute values. Okay, this number is going to shift us up or down. Also the same as absolute value graphs. This number is going to change the slope, which is also the same. The only thing that's going to be different is that if there is a negative, that's going to flip the graph along the x-axis, which is pretty much the same as what happened with absolute values, but obviously square root functions are not going to look like absolute value functions. So when we flip it, it's going to look a little different. So remember how we have parent functions of graphs. So the basic parent function is y equals the square root of x. That is our base level square root function graph. So for this graph, we start at the origin. We go over 1, up 1, over 2, up 2. It's going to look like half of a parabola. Okay, so that's our parent function. That is the most basic square root function that we can possibly have. But when we add stuff to our function, it's going to change what it looks like. So let's take the example of y equals square root of x minus 1 plus 2. We're going to apply the same exact rules that we did to absolute value functions to our radical functions or our square root functions. So this number tells me left or right. And it's going to be the opposite of what we think it is, just like absolute value functions. So this is going to cause me to shift right 1. This 2 is going to tell me up or down. This is going to cause me to go up 2. So my new vertex is right 1, up 2. So when I graph that, that's my new vertex. And my slope is still up 1, is still 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. So that is that that radical graph. Same exact rules for our vertex. Alright, what if we change the slope? What if we change how it looks? Alright, so this time I'm not adding anything inside, I'm not adding anything outside, I'm just changing my A value. So the negative is going to tell me that it flips, and the 2 is going to tell me that my slope increases. Again, it's exactly like our absolute value functions, it's just a different shape. My vertex has not changed. Why has my vertex not changed? Well, I don't have anything inside my square root, and I don't have anything on the outside, so my vertex is still 0, 0. But now my slope is 2, and I flipped it upside down. So instead of my graph going this way, my graph is going to go this way, underneath the x-axis. Okay, so just like when we had our v's, we would flip them. Now when we have our half of a u, we're going to flip them. So instead of being a frowny face, it's going to be a smiley face. Okay, so, and my slope is now 2. So instead of my slope being 1 over 1, it's going to be 2 over 1. So the negative flips it, the 2 increases our slope. If a is greater than 1, our slope increases. If a is less than 1, our slope decreases. This should all be familiar from what we just finished up with absolute values. All right, let's do one more where we put it all together. Again, these are the super basic ones, okay? So let's do y equals 1/2 square root of x minus 1 plus 1. All right, so this is putting it all together. It's not a negative, so I'm not going to flip it. I have a 1/2, so my slope decreases. Instead of being 1 over 1, it's now 1 over 2. This number is going to shift me right 1. This number is going to shift me up 1. So my new vertex is an x of 1, a y of 1. 1, 1. And now my slope is 1 over 2. So I'm going to go up 1 over 2. Up 1 over 2. And that is my new graph. If I put a negative out in front of that, my graph would simply be on the opposite side of the x-axis, and that was a terrible reflection. But instead of being at positive 1, 1, it would be at 1, negative 1. We would flip it over the x-axis. And actually, it wouldn't be at negative 1, 1. It would still have the same vertex. It would just be this way. Keeps the vertex. Sorry about that. Our vertex doesn't change with a negative. Alright, so let me grab your worksheet that I gave you. Alright, your worksheet, that's the answers. Oh, I only have the answers. Rock on. I'll go into your packet. So, as an example, I'm in your packet. You don't have your packets, I don't think, and that's okay. I'm just going to do one example for you. So look at number 42, okay? There's no a on the outside, so my slope is still 1, and it is going to be right side up instead of upside down. I have a 6 on the inside of my radical, so that means I'm going to move left 6. And I have nothing on the outside, so my new vertex should be negative 6, 0. Right there. My slope is still 1 over 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. This should be, I'm not going to say it should be easy, but it should be beginning to be second nature to you because of all the absolute value problems that we've done. Okay, so on your worksheet that I gave you for homework that I told you you wouldn't be able to do until you watch this video, I want you to do 1 through 6. 1 through 6. I'll put that on LMS for you. So just the front page. They are all ones that you can do. There's nothing weird. Nothing you have to worry about. It's this simple. Okay? You're going to find out what your vertex is by using your rules of H and K. You're going to figure out if you're going to flip it, and you figure out your slope. Alright, if you have any questions, alright, I am going to be on LMS throughout the day. You just let me know. I will also be posting on LMS the schedule for exam week next week for K through 10th grade, which obviously doesn't include you guys. I'll be posting that as a reminder of what day you have to be at school and what your requirements are as juniors and seniors. And I will talk to you more about that tomorrow. So the only thing I need from you tomorrow is 1 through 6, problems 1 through 6. It'll be an effort check. If you don't have it done, it'll come off of your participation for the week. Alright, let me know if you have any questions. Email me, message me on LMS, whatever works for you. Alright, and I'll see you guys tomorrow.